In fact, it could be suggested that NIST never explained the collapses by gravity alone because it would be impossible to do so without violating at least two of the most fundamental laws of physics. One is Newton's third law of motion, which states that for every action there is an equal and opposite reaction. This means that two opposing forces will neutralize each other. In a head-on collision, the two cars absorb each other's kinetic energy and transform it into physical deformation or damage. After that, the system comes to a rest, as there is no more energy to be dissipated.
The top section, pushing on the bottom section, it's going to meet equal forces as it goes. Both sections are going to be demolished at the same rate. So by the time you've crushed up 15 stories below it, the top 15 stories are also going to be crushed. And so there's nothing left now to crush the rest of the building.
Something of this kind is what we should have seen when the top section of the towers collapsed onto the lower one. The upper and lower sections should have mutually destroyed each other until all the energy is dissipated and the system comes to a rest. Alternatively, as shown in this experiment with two towers made of snow, the top section could have fallen off to the side after the initial collapse. What could not have happened is this.
A little tiny chunk of the building can't possibly fall and crush the entire structure below it.
This is such a simple, fundamental concept that architects and engineers were astonished in seeing it totally ignored by NIST.
This is high school physics, and our whole society is being led to believe that these fundamental laws of physics, hard science, don't apply anymore.
But even if we assume that the top section of the tower had enough potential energy to destroy the rest of the structure below, it could not have done so at the speed it did, which was near freefall speed. That would have violated an even more important principle in physics, known as the law of momentum conservation. This law states that the total energy within an isolated system must always remain the same. As we have seen, the energy can be transformed within the system, from motion to physical deformation. But for the deformation to begin, the velocity must decrease in order for one kind of energy to be transformed into the other. No new energy can be added to the system. One particular example of momentum conservation is freefall. Freefall happens when the only force applied on an object is gravity. This means that all the potential energy contained by the object is converted into vertical motion. As soon as the falling object hits an obstacle and breakage occurs, the speed must decrease because some of its energy needs now to be converted into physical breakage. It takes energy to break things apart, and that energy must come from within the system. Thus, the falling rock cannot keep falling at free fall speed and break apart at the same time because it doesn't have enough energy to do both.